So this one we are going to start it from the ground. And what is the ground of calculus? We are going to deal with first the slope of a line. Understanding the slope of a line, understanding the slope of a secant to a curve, then from there we can build up the differentiation formulas, and you will understand how that general formula came about, right? Now here what you're going to do, if I have my x-axis, understand, and have my y-axis, have a line, then that line I want to find a formula to calculate its slope, meaning how slopey it is. This one, to calculate how slope a line is, it depends on the difference of y against x, meaning the rate of change of x against that of y. That's what it means by our slope. So in this case, if you look at this, if I get a value on my x-axis and find the corresponding y value, and get another point on the line, trace it to my x-axis and what the corresponding y-axis, then in this case I can find the difference between, meaning what, you know, slope, you can take any 2 points on the line, taking on the any 2 points on the line, trace it to the x-axis and trace it to the y-axis, get their difference. Then here in this case, what is the difference? The difference actually will be 1 minus x2 minus x1, and the difference on the y-axis will be y2 minus y1, as the way you guess it, right? So in this case, what you're going to do, we say that the equation of the slope is difference on y all over difference on x, which is equals to y2 minus what, y1 all over x2 minus x1. I guess you understand, right? Now let's move it further to secant. Secant means what? A line that touches 2 points on the circle. I get it, right? So in this case, if you continue the second line, again I have a curve. Let's call it what? F of x. Now in this f of x function, I can at least have a second line. That second line, trace it to the x-axis, again the same thing. Now in this case, instead of calling it what, f1, sorry, instead of calling it y1, I will call it what, f of a, right? And have another value. Don't forget that the first value I choose is a constant value. That constant value have any other value, call it what, x, again I can get what, f of x. So in this case, having a constant value, call it 2, and trace it to what, getting any y, any x value. In that case, I can able to get the second line slope. So again, the same thing. What you're going to do, trace it, get the difference on x and the difference on y. And what is the difference on x in this case is what, x minus a, and the difference on y on this case is what, f of x minus f of a. So in this case, that's what you have. My m sec mean what, the second slope, right? So in this case, that's the formula, and you get it right. Here we have. Now we can develop it into differentiation, meaning I want to get the how slopey a point on a curve is. Now in this case, I must reduce this line, these 2 points, in such a way that it will be very close to this, because you know that if this point come close to this point, then you can see that I will no more have any secant, but I will have a what, tangent. I get in this. Now let's continue. Here, if I replace my a with x and replace my x with x plus h, what does that mean? Meaning what, I just want to give it a gap between my first point and my second point. That's why I call it h. That one is a constant value, alright? So in that case, let's go guys. I replace my x, my f of a with f of x, because you already know here in this case I choose any value, and replace my other one with f of x plus h, because you know that this corresponding value of that point is there, right? With a small notch. So continue with that, the same thing, difference on x all over difference on y all over difference on x. Again, continue with that. I can cancel out those things. I think if I open this bracket, I will have x open on y. Since x and x they are what, the same magnitude with different sign, then you can cancel out, right? You got it. Continue. So in this case, we continue with this and have this one as my formula with the what, second line. I get in this in terms of h as a notch. Now this formula, this point is very crucial. If we get this one, then we can develop it using limit to what, to bring it very close to that point, because limits mean as h decreases up to what, almost zero. That's what it means by the limit of h as h approaches the limit as h approaches 0. Don't forget that this formula is the same as our formula in the second line, right? If that one is this formula, then I think the only update we have here is what, adding a limit here, because I want to reduce it up to a point where it is almost negligible. Reason why I cannot take h to 0, reason why I cannot reduce this gap up to this point to 0, because this denominator cannot be 0. Though it can be very, very close to 0, that's what we call by what, limit as h approaches 0, right? Continue with this. I'm approaching. You can see that 0, h is decreasing. As h is decreasing now, we can see that this h is almost 0. If you look at the line is no more a secant, but it's a tangent to a point. Now that tangent, if I calculate the slope will be the slope at a point, or the slope at what, x equals to something. It can be the slope at x equals to what, 3, or x equals to what, 4. Any value of x, if you calculate, you will get the same thing. So in this case, we get that formula as what? This is the formula of what? This is the general formula of what, differentiation. You can understand it. Do you understand? Do you get intuitive understanding of this now? Very easy. It's just a concept. Alright? Understanding these stuff, now we can continue to find some solve some equation. Find the equation of the tangent to the graph f of x equals to 2 equals to x squared at x equals to 3. Alright? So in this case, again, I continue with this. What do you have? The same formula, right? It's the same formula we proved, the general formula of differentiation. What you're going to do, anywhere you see x squared, put there what? X plus h. Alright? X plus h. Let's give it a try. Now, if I do that one, you see, x squared was what? This x was squared. So anywhere I see that x, I will replace it with this on this function. Now this must be what, squared, because it's f of x. Again, this one was f of x, which will be what, the same as that. Now replacing those things, I can what? Can open my bracket, have x squared plus 2xh plus what, x squared. I think that one, if you understand basic algebra, you will get that right? So in this case, we continue with that. Open the bracket, have those two x's, the same magnitude but different sign, then they will cancel out. Done. Now here is what I have. In this case, you can see that my tangent, the slope of the tangent will be limit as h approaches 0. That of that, then I can factor out h, and this h they can cancel out, right? If they can cancel out, now in this case, I can continue with this, and that one is my what? My slope. The slope of the tangent equals 2x. Now in this case, what we're going to do is only to substitute now x equals 3 on the equation, the slope of the tangent line, then find the corresponding y value on that x, right? So in this case, if we continue with this, we can have this is the definition. Equation of any tangent line at a point with a slope of m is given as what, this y equals y minus y1 equals to the slope of the tangent x minus what, x1. That's what they have, right? Now what you're going to do, how can we get the slope of the tangent and the point? The point is very easy to get. Don't forget that we've already have what, x1. What is x1? 3. Substitute it back in the function. Then there we have what, our y value. And what is our y value? It's the same as what, f of 3, right? F of 3 is our y value since x is our what, 3. Now in this case, if you get it now, our y value will be equals to 9. So here we have the point is what, 3, 9. The slope of the tangent equals to what, 2x in bracket. So here we have the tangent line equals to what, m tangent. The tangent is equal to 2 in bracket 3 equals to what, 6, which is the slope of the tangent equals to what, 6, right? So continue with this, I will have y minus y1 equals to tangent line, which was the same formula as that. Now in this case, all what we need to do is what, substitute. Don't forget that our y1 in this case is what, f of 3, and that one is 9. So and our x is 3. Continue with this, we can have what, this one as the value, and here we have as what, the answer, right? So getting this, we are done. Now y equals what, 6 6x minus 9. Then continue, have another equation, which is what find the equation of the tangent line to this graph, which is equals to f of x equals to 1 over x, right? Now in this case, at x equals to 2, that's what you have, right? At x equals to 2, do the same thing. All what you need to do is just pause it and try, alright? Now let's continue. Now using the same formula as what the tangent is always equals to limit as h equals to 0, f of x plus h minus f of x all over h. Continue with this, do the same thing. Substitute wherever I see x on my f of x function, I'll substitute there what x plus h, which is f of x plus h, right? Now in that case I will have 1 over f of x plus h, 1 over x plus h minus 1 over x. Finding the LCM there, I'll get this as my value, and here we go. As you can see that I will have what x cancel x, since they have the same x with different magnitude, sorry, the same magnitude with different sign. Then if I cancel it out, I continue and get this one as. So here I will cancel out my h values, and in this case if you continue, here we go. Now my limit as h approaches 0, if you get this the same thing. Now what you're going to do, limit as h approaches 0, I can just substitute my h values and get the answer as, don't forget that x times 0 will go to 0, and answer will be equal to negative 1 over x squared, right? So the same thing, what you're going to do is take this value of x and substitute it on this slope answer and get what this one as a numeric value, as a number. So in that case again, I will take this one and substitute here to get what f of 2 to get my corresponding y value. Let's go and see that. The same thing, that's the definition, right? You can remember. Now in this case again, I will have what, that's the formula, right? If you get the formula now, you can just find the point. The point is 2 comma f2, and my f of 2 equals 1 over 2, which is equals what my y1. Continue, and f of, that's the answer. Here is the point 2 comma 1 over 2. Continue with this, I will have negative 1 over x squared, which is the same as my what slope. I'll just substitute 2 there and get what 1 over 4, negative 1 over 4. Now if I substitute all this term in the equation, then here we get y minus f of x plus 1. Reason why I use f of x plus 1 here instead of x1, y1 is the same thing, right? So here in this case, here we go, y minus 1 over 2, which is the same as my y1 in bracket, so equals to negative 1 over 4 x minus x1, x minus 2. Then here we go, and if I simplify it further, I will get this and this. Here we continue, x all over 4 plus 1 over 2. If I move 1 over 2 to the other side, then I will have just fractions there. Simplify it further, 1 over 2 plus 1 over 2 is half. And here we have, please, that's the end of the two questions and the definition, the proof of the calculus formula, differential formula. Now don't forget to subscribe and click the like button so that it will boost the YouTube algorithm and show it to many people, right? Please do that. See you later with the next videos, which will be on some application of this differentiation on different areas like economics and physics, right? See you later.